Hello, this is Belshia here, Assistant Professor CSE SA Engineering College, and my topic for today is searching algorithms. Searching is common topic and everyone is aware of searching, we can know. First, let me tell what is searching. So, searching is something that we can call it as a procedure. When we doesn't know anything about a word, we go for searching in a Google search engine. So, let's take an example like Apple. The word Apple, we basically we want to know the meaning. We'll go for searching in a Google by typing Apple, the word. It retrieves information based on fruit. Sometimes it retrieves information about fruit, and sometimes it retrieves information about the Apple iPhone. So this is how the searching generally refers to. So next slide. Searching algorithm. So how those informations are retrieved, that is where the question starts. So it is based on certain algorithms. So what are those algorithms? There are so many algorithms involved in order to retrieve the information. So in that, the mainly used algorithms are binary search and linear search. Those are the basic major searching algorithms which is used overall. So first we can see some of the introduction about linear search and then about binary search, and then we can solve one is on linear search and another one is on binary search. So where this searching algorithm is applied, we can see the database. So database, it retrieves information based on searching, and also we get in a Google search engine also we are retrieving information based on the search we are giving. So desired information will be located among the collection of data in the search engine. Next, coming on to linear search. So first, what is linear search? From the word itself you can understand. The linear search refers to sequentially searching. So sequentially searching in the sense, here they have given 7 boxes. So index from 0 to 6. So now I am here to search the element 15 here. Okay, now I am going to search element 15. So 15 is located in the index 4. So how I will search? Linear search is a method. It starts from one end and it proceeds till the end. So here I will go for first A of 0. So A of 0 consists of 92, not 15. So again, if it is not retrieved, then I will move on to the next A of 1 and A of 2. And A of 3, finally to A of 4. So A of 4 is the value 15. So there are totally 7 elements, but in the 5th element is our information. So one by one I am searching in order to retrieve the information which I want. So that is the linear search. Next, there is some algorithm. How does that algorithm works? So first, let's take an example. We have a bag full of balls and my key ball. See, you can see here the explanation is every element is considered as a potential search for the key. So now I will consider my key as red ball. In bag full of different color balls, my ball is red ball. So I am going to search if the element is found equal to that key, which means if I find a red ball inside that ball, that's all, my search is successful. I will take that ball. And here, same way, the algorithm retrieves the index of that particular element is returned if I get that ball. If I am not getting that ball, ultimately it returns no match found. So this is how the algorithm is working on the problem. Next, coming on to program. So you can see I have taken C program. So this is basic declaration followed by array of elements and then search. Search is something that, as I have mentioned, what we are going to search. Those it can be numbers or alphabets. So that I can give in this search, and I is the index and N is the total number of elements. So first we are here to print now. First we are going to print enter number of elements in an array. See, you can see here, enter the number of elements in an array. So they have entered 5 and then followed by what are those 5 elements. So those 5 elements can be entered one by one. So here the for loop works for that process, and then you have to enter a number which you have to search in this list of array. So here they have entered 4 value. Now coming on to program, so they have given, we have to search number 4 in the given list of numbers. So before going on to, there is some logic here, you can see. Okay, first they have initialized I value as 0. So previously we have seen index starts from 0 value. So 0, and then I checks the value whether it is less than n or not. In this program, n value is 5. So now I value is 0. 0 is less than 5 obviously. Then it checks array of 0 is equal to search or not. So array of 0 value is again 5, and 5 is not equal to the value 4. It is not equal, right? Then if it is not equal, again the I value will be incremented. Again 0 will be 1. Again the same thing is checked. So 1 less than 5. Again a of 1 is equal to search or not. It again checks the value. Again if it is not equal, then again it will increment. The for loop will be running on that way. So finally, okay, you can see the value is 5 again, and next is 6. 6 is not equal to 4, and in a of 2 the value is 4. So here we are stopping our program. So here you can see, so a of 2 is equal to search number is 4, and we are retrieving those a of 2 here, and see you can print 4 is present. Since our search number is 4 is present at location I plus 1. So array of index is 2 and our location is I plus 1, which means 3. So you can see the output, 4 is present at the location 3. Now coming on to next statement, that is break statement. See, we have total number of 5 elements. In the third position we have found the element 4, and still there are 2 more elements to be searched, that is 2 and 9, but those are not element which is required for us. So here if we give break statement, after retrieving the desired output, the program stops there and it retrieves our information alone. So in order to save time, we are giving this break statement here. We have discussed one case. Now another case is something that if we give an element which is not in the list, then ultimately this if case will be working it out. So we'll be going on to that boxes. We'll check one by one, and we can take the value 3. So if 3 is the value, we'll first go on to a of 0, that is 5. The required element is not found. Then a of 1, 6. The required element is not found. Likewise a of 4, that is 9, which is again not the required information. So ultimately here our 5 is equal to total number of elements here. So here what does it mean? Which means our element is not found in the complete list of elements. So ultimately it presents like %d is our searched element, that is 4. Now 3 isn't present in the array. So likewise the output will be retrieved. So this is how the linear search will be working. And if we come on to the time complexity and space complexity, first thing is best case. Best case is something that Okay, so my searching element is 92 for an example, and when I start my search, immediately I found 92. So that is a best case, which means immediately I have found the element, which means I did not spend any much of space as well as time there. So we can give order of 1, that is straight away the constant. Worst case is something that total number of element is 5 in that case. So if the element is not found in all that 5 list of element, then ultimately at last order of n will be the worst case. So order of n is worst case. Here linear search finds it a problem where order of n should be rectified. How it is rectified? So ultimately we are going for binary search in that case. Within a couple of minutes I will tell why we are going for binary search and how this order of n is rectified in binary search. So next, coming on to auxiliary space, that is space complexity. Since array size is fixed in this position, so we doesn't want much space. So ultimately we give straight away constant, that is order of 1. This is how the complexity has been calculated. The question from the gate is the average number of comparisons required for a successful search for sequential search on items is. So already I have given about best case and worst case. So now they have asked you to find average case. So here you can notice that is sequential search. Sequential search is another name of linear search. Again, average case is something that usually when we find an average, what is our formula? Sum of all numbers divided by total number of numbers. Same way here they have taken sum of all cases divided by total number of cases. So which is equal to, here we can list like 1, 2, all the cases will be an sum divided by total number is, total number we will represent it in n. So ultimately you would have gone through this values arithmetic series. So ultimately this refers to n into n plus 1 divided by 2. Then whole total divided by n value, total number of values. So n and n gets cancelled. Ultimately n plus 1 divided by 2 is your answer. So this is how we calculate the average case of sequential search. Next, there might be questions like, sometimes they may give you a problem and they may give a set of array list and they'll ask you to find the output of that particular program, or else they'll give some outputs and they'll ask you to find the search key. So based on level of exam, they might ask different type of questions. So this is how the linear search is carried out. Now let's go on to the binary search. So what is binary search? Generally binary search is also one of the search technique that is used for sorted elements. It is very good in case the elements are sorted. So how we will proceed? See, binary search follows divide and conquer technique. So divide and conquer technique is something that there is list of 10 elements. It will divide it into 2 parts, which means 5 elements one part and 5 elements another part. So same way it also divides based on the mid value. So with that they will find the mid value. If it is matching our expected search, then ultimately it returns the value, or else it moves on for the further search. So how to implement this binary search algorithm? There are 2 methods. Those are iterative binary search algorithm and recursive binary search algorithm. Now here I am going to concentrate on iterative binary search algorithm since the time is stipulated. since the time is limited, I'll take alone iterative binary search algorithm. So here there is an example. They have given some elements 10, 12, 24, 29, 39, 40, 51, 56 and 69. Our key value is 56. Key value is 56. So first, initially, this is our lower value, that is 0, and 8 is the higher value. So now they have asked you to find the mid value. Based on the mid value only, we will be splitting using that divide and conquer technique. So mid value, based on that, mid value is equal to, here they have given 0, 0 plus 8 divided by 2, which is equal to 4. So 4, it consists of 3. This is a mid value. So now we are going to calculate. So mid value is greater than, or there are 3 cases. One is the key value is equal to that of array of I, or else the key will be less than array of I, or else key will be greater than that of A of array I, which means here I refers to mid value. Okay, so when it comes to mid value, here we can see the key value is not at all equal to the mid value. 56 is greater than, which means key is greater than that of A of I, A of mid value, which means then how we need to calculate is lower we need to add it to the A of mid value, which means here mid value is 4 now, then we have to add 1 to it. So ultimately 5 is your L now. Okay, so now our 5 is the L value. Again, now 8 is same, there is no change in the 8. 8 remains constant as high value. Now the mid value changes again, which means same formula should be used. 5 plus 8 divided by 2, which means 13 divided by 2, 6. So 6 is the mid value. Now again we can check 51 is equal to 56 or not. It is not equal. It is less than, 51 is less than that of our mid value is less than, our mid value is less than key. So again what we need to do, L plus 1. So if we do L plus 1, which is equal to 7, already 6, now it comes to 7. So now L value will be 7. So ultimately now our mid value will be 7 plus 8 divided by 2, which means 7. 7 will be your ultimate answer and mid value will be retrieved. So this is how we calculate the mid value. Again, accordingly we will be furtherly navigating to the location which is the searched element ultimately. Okay, now same way we are going to see about the binary search C program. Here again I have chosen C program here. This is the basic things again. You can see I is an index and low value, high value and mid value is additionally added when compared to that of linear search, and key as usual search element and array. Now printf, same thing is followed here. So first they are asking you to enter the number of elements, that is 5 again. 5 again, and followed by what are those 5 elements. Likewise for loop has been added and 5 elements has been given, 1, 2, 3, 4, 5. As I have mentioned, it works, binary search works well with that of sorted elements. Now coming on to next point, that is enter value to find. What value we need to find, those has been entered here. Here they have asked to find 4 again. See, first we have to initialize, we have to go to low and high. High is something that total number of elements may be 8. Here they have given 5 elements. So 5 minus 1, which means 4 index will be there. 0, 1, 2, 3, 4. So mid value is calculated accordingly. After that, there are 3 cases as I have already mentioned. Those are array of mid is less than key, of array of mid is greater than key, or array of mid is equal to key, which means okay, we have 3 cases. So A is A of mid is equal to key, then it is a searched element and it retrieves the element straight away. You can see here, if array of mid is equal to key, then percentage %d found at the location, it will retrieve the key, that is maybe 4 found at the location wherever it is found, those plus 1 will be retrieved. So after that, the break statement is given, the program stops. So before that, array, if A of mid is less than key, then automatically lower this side, left hand side should be taken to mid value, and we have to add 1 to it, and then there the pointer starts. So if the key is greater, so here they have given if loop and else loop. Else loop is opposite of array of mid is greater than that of key value, then the high is equal to mid minus 1. This is how it has been calculated. Again we have to use the formula mid, then we have to find the mid value, then again the mid value matches the key value or not, we have to figure it out, and after figuring it out we can retrieve. So this is how it works, but there is one more outer condition, that is low and high. So they have given in the while statement. So if high is greater than low, then no problem, the elements are present. If lower becomes greater, then ultimately the result which we are searching is not found in the entire list. So that's where this program is concluded. Same thing. Here they have asked to found 4, and 4 is in the location A of 3. So 3 plus 1, 4 has been retrieved. So if the element is not found, it will tell us 4 element is not found in the given list. Okay, now we are going to look on to time complexity. There are 3 cases: best case, average case, and worst case. First, let us tell what is best case. So best case is something that when we have the value low, first we calculate low and then high, then mid value. So the mid value itself is a searched element, then ultimately the constant value is retrieved, that is order of 1. So it is a best case. Average case and worst case, I'll tell in the program while solving the program. Coming on to auxiliary space, again the array size is fixed here. At the same way, no additional extra memory is not needed. So we are retrieving constant value, so order of 1 again. Now coming on to problem. Okay, given a sorted array, what can be the minimum worst case complexity to find the ceiling of a number x in a given array? So they have asked you to find the worst case time complexity. So you can see the ceiling of an element x is smallest element present in the array greater than or equal to. They have given 3 cases. At the same way, you can see they have given an example and list of sums: 12, 67, 90, 100, 300 and 399, and they have asked to search 95. Total number of element is 100. So here we have a mathematical formula, that is log of b n is equal to k, which means ultimately b power k is the answer. So here you can see 95 is going to be searched, so which means it will search all the element, because all the 6 element doesn't consist of 95. So our value will be log of 2, n is 100, which is equal to 6. Ultimately 2 power 6, ultimately answer will be 6. So this is how the log n formula has been retrieved. Order of n is an average case. Same way, worst case is also order of log n. Here I said that linear search is lesser when compared to that of lesser in the sense lesser effective than that of binary search, because log n has been determined like linear search is something that if 10 elements are there, all the 10 element has to be searched in order to retrieve the information one by one sequentially. But coming on to binary search, it will split into two halves. Which half is necessary, those half will be checked for the searched element. So here the time has been saved when compared to that of linear search. So here always people used to go for binary search rather than that of linear search. Here I am closing my chapter. That's the end. Same like linear search, we have binary search program also. It can be solved at any time. At the same way, somewhere they may ask you to find the output, or somewhere they may ask you to find the values. So this is how you have to do it. That's the end of today's chapter, and later on we'll see in the further session. Thank you so much.